In this project, we are going to be talking about fetching data with AWS Lambda. We're going to learn how to retrieve DynamoDB table data using a function in AWS Lambda. Now, if you are doing this project as a part of the 12-hour project marathon, welcome back. And this is going to be a straight continuation of what we've been working on over the last two projects. If you are seeing this project for the first time, you haven't done the first two projects in the marathon or any of the 3-tier architecture series that this is a part of, just know that you are so welcome here. You can definitely do this project on its own. You don't need to do the first two projects to catch up here. Just start from step 1 here and you can still make it to the end easy as. It's more that this project is a part of a big series where if you do every single part, you can pull together a beautiful 3-tier solution that is a fully functioning web app as well. Okay, so let us jump into it and talk about what this project is going to be about. Now, this project is about fetching data with AWS Lambda. And what you can imagine when you think about Lambda is that you think about building applications that can just grow effortlessly to handle thousands or millions of users without you actually needing to manage the servers behind them. That's the power of serverless computing. That's the power of Lambda. This project is your introduction to serverless. You will learn how to use a serverless AWS Lambda function to retrieve data from a DynamoDB table. Quick pause here. If you were doing the 12-hour project marathon, you might think, oh, this seems very familiar. It feels like we've done the AWS Lambda function and we've even created the function already in the previous project. And that is true. But the one thing that we definitely didn't cover yet is DynamoDB itself and how you can link the function and actually retrieve real data from a database with your function. This is perfect for roles. This project is perfect for roles like backend developer, cloud engineer, cloud architects, where it is a key responsibility to create these scalable cloud solutions that can handle large amounts of data. In this case, scalable, Lambda, handling large amounts of data, DynamoDB, and Lambda both. So what we're going to be doing today, we have this little process diagram for us in this project. We can create a database table to store some user data. Cool. And when that's done, we can create a serverless function to retrieve that data. So that's a Lambda function we're going to create. We can write some tests to validate if the function can actually fetch data from DynamoDB. So is our function working? The Lambda function is supposed to fetch data. Can it actually fetch that data? Let's find out. And then you can secure your function with the proper permissions and then secure your database with an inline policy as well. That will be our secret mission today. Very nice. So with all that checked off, let us talk a little bit about the 3-tier architecture and where it sits. So in this project, you are diving into the data tier of your 3-tier architecture, and I'm going to move myself away. Okay, cool. So this project tackles the last tier of a 3-tier architecture solution. In the presentation tier, you set up the front-facing interface of a website, of a web app. So this is the website that users can see and click on. You use CloudFront to set up that presentation tier. So you use CloudFront to actually distribute the website around the globe so that the website loads very fast for all your users. Next is your logic tier. So the logic tier is like the brains of your web app, the actual logic around how it does what it's supposed to do. Is your web app supposed to retrieve some data for its users? Are users supposed to be able to search for things? Are users supposed to be able to upload PDFs or process PDFs? Once you realize what your users are supposed to do in your web app, the actual code that processes those actions, that actually creates these results for your users, that sits in the logic tier. And our logic tier that we've set up for this 3-tier architecture solution is in a Lambda function. And how your users' requests will map to the right function is with API Gateway over here. Okay, and finally, we have our DynamoDB database, and this is our data tier. So this is where we actually store the actual data of who are our users, what are our products, and maybe what are the blogs and articles and videos that belong in our web app, so that when our functions, when our backend needs to use it, needs to retrieve it, this is the place where it's going to retrieve from. This is like our home base for all of the data that makes up what our Lambda function is trying to get. So our Lambda function is trying to get data, it's going to get it from DynamoDB. I feel like that was a much more straightforward way than that long ramble I was on for a second there. Okay, we've got Alex 10 in the house. Alex, great to meet you. I know we haven't actually chatted one-on-one yet, but I definitely remember seeing you around in the community, and also as one of the top project completers at NixWorks, so welcome. Great question from DevOps Methodology as well, asking, is there something involved in securing your serverless function and database with proper permissions and policies in this project? Wow, great question. And I feel like it's almost like Jinx DevOps methodology, because it is definitely one thing that we'll be working on in both the project steps and the secret mission. Okay, so we're about to get started. Are you ready for this project? Woo, let's go. Like every other project, the first thing we're going to do is recap. What are we actually here to do today in this project? Do you think you can answer? In this project, I will demonstrate. I'm doing this project to learn. Try answering this question yourself, and then I will submit my answer too. Oh, we got Ria in the chat too, saying excited. Ria, that's so sweet of you. I'm very excited. Even more stoked because you're here too. All right, team, let's get into it. In this project, we will demonstrate how to use AWS Lambda to retrieve data that's in a DynamoDB database. We're doing this project to learn how to set up the data tier of a web app and connect that with a Lambda function too, i.e. the logic tier. You're doing two tiers at once in this project because you're setting up the data tier, which is the simplest part of this project, to be honest, and then you're setting up the connection to AWS Lambda, which is actually the harder part. And Michael says, let's go. Oh, you guys are the best. Thank you so much. This energy is amazing, isn't it? You guys really make us go further. This is really cool. Thank you. All right, all done. So let's set up DynamoDB now in our very first step for this project. So we're going to create a DynamoDB table, and that's going to be used to store some user data. All right. In this first step, we will set up a DynamoDB table because this will be how we store user data. Okay, our web app is going to store some user data. Where is that going to live? DynamoDB. Let us go into our AWS Management Console and open up the DynamoDB console. Where have we been this entire project? We've been in the Oregon region. So let us make sure that when we open DynamoDB, we stay in the same region. Okay, let us open this up. All right, it's opening up. Ha, how good. And we're still in the Oregon region, so that's a double win. Very nice. And I'm gonna close, no, I'm not gonna close it, but I'm just gonna reorganize my tab to keep these ones away because we're not really touching it in this project. Okay, And what is DynamoDB? This might be your very first project using DynamoDB. And if it is, that's cool. If it's not, you can try challenge yourself to add a definition of DynamoDB in the chat. See how that goes. All right, DynamoDB, at its very foundation, is a database service. So what that means is you would use it to create a database and store your data inside it. It really stands out because AWS has a bunch of different kinds of database services, all for different kinds of use cases. What's the use case for DynamoDB? So DynamoDB stands out as a database that has really high performing in terms of speed. So if you really need to grab data in a very quick way, DynamoDB is the guy. Oh, sorry, didn't mean to just call DynamoDB a guy, but DynamoDB is like the person to call. And that makes it a really great choice for apps that just need quick access to large volumes of data. Games. Imagine how quickly your game needs to react. For example, a leaderboard that's constantly changing, a game, like game characters that are constantly adding or getting associated to different accounts. So that's a great use case of DynamoDB. DynamoDB is also a great database if you are trying to store data that's just completely random or flexible, data to data. What that means is when you have a relational database, like a spreadsheet, every single row, every single column needs to be aligned and filled out. If it's not filled out, it was still going to be like no data. Let's say you have like rows and columns of day and, I don't know, weather or temperature. And let's say there was a day where you just didn't measure the temperature for the day. You're still going to have to actually enter something in that field in a relational database to say no data or 0. And that maybe doesn't matter when you only have a piece of data. But imagine if you have a million pieces of no data. That makes your database look a little, like incomplete. And at the same time, even entering like no data can take up a bit of space. So the moment that scales, even having no data can end up taking space in your database. In contrast, DynamoDB is a NoSQL, or it's a very flexible database. So if you have a day where you didn't measure a temperature, that's totally fine. It's not going to take up space. What if you have a day where instead of measuring the temperature, you decided to measure like the wind speed, like something else you decided to measure? You can just do that in DynamoDB and just say, oh, instead maybe like you just added wind speed as like another attribute for the day. But that would not fly at all for a relational database, where the moment you add almost a new attribute, you add that attribute for every single piece of data in the database. Whereas for DynamoDB, what's great about it is you can just add that attribute for that single piece of data, and it doesn't affect the other pieces of data. It doesn't add unnecessary space, or it doesn't take up unnecessary space. So that is a great thing about DynamoDB. Bit of a spiel. I did not expect to go into it in so much detail, to be honest. But those are two great things to know about DynamoDB: speed and flexibility. We also have a dedicated DynamoDB project, so you can definitely check that out too. It's called Load Data into DynamoDB. In our case though, why are we using it? Don't forget, we're using it as a part of our 3-tier architecture. It takes care of the data tier. It's going to be storing some user data for us. So let us create the table and call it user data. It's how intuitive, isn't it? So let's go into tables and let's create user data. Great. Now for the partition key. What is a partition key actually? It's a bit of a concept. And a partition key, look at this interesting definition. It is a hash value that is used to retrieve items from your table and allocate data across hosts for scalability and availability. Actually, a great definition, but to see technical words like hash value might be a bit of an overwhelming feeling. Think of partition keys as like labels or things that help you separate out your data. If I have a partition key that's like user ID, that means you can split up your data based on user ID. User ID 1, user ID 2, user ID 3, 4, 5. Every single piece of data in your database is going to need to have a value for the partition key. So the partition key basically determines that one underlying ingredient that all your data will share. every piece of data, for example, now is gonna need to have a user ID. And the great thing that this definition mentioned is that it allocates data across hosts for scalability and availability. And what this is really trying to say is you can use user ID to split up your data and store it across different servers. So instead of having to store your entire database in a single server, what if you could actually split that up across different servers? And you can say like user IDs from this to this in this server, user IDs from there to there in another server, and you can easily still join up your entire database's data by using a partition key maybe to merge it all together again. The reason why this is so scalable is because now you have different servers that's hosting different parts of your data. So to search for specific data is actually a lot faster now. And that's the reason why DynamoDB is so good for fast retrieval use cases. It's because the data is split up across all these different hosts, all these different servers. All right, that was awesome. I love learning about DynamoDB and partition key actually. Sort key is another thing that you can use like a second kind of attribute to break down your data even more, but we're not gonna go there. It's an optional field. We have Alex10 also in the chat asking a cool question. How do we outline the project's purpose, desired outcomes, and key performance indicators? Do we have a software for it? Ooh, this is a very good question. We usually have prompts at the start and at the end of a project for that. That's a space for you to outline your project's purpose, what you're trying to do with it, what you've learned from it, anything that you're trying to achieve with that project. Are those prompts enough? Are you looking for something that automates that work for you? Give us a bit more information, Alex, and maybe we can talk a bit more about this too. Okay, but we have set up user ID as our partition key. And let us head back into the steps where we're going to just leave the default setting for the rest of the options, create our table, great, and then answer a question, also great. So let us create our table here now, and let us now answer the question. To set up our project, we created a database using DynamoDB. DynamoDB is a NoSQL database. It is very fast at data retrieval, very fast and flexible at data retrieval. So it's very fast at data retrieval and flexible for data storage. The partition key. The partition key is user ID, which means the key identifier for each data is its user ID. If I want to search for data, I'm searching by the partition key. Okay, done. Okay, great work, team. Great stuff. You've taken the first big step in this project and you've set up your DynamoDB table. All right, we're breezing through it. Let's add some sample data now to the user data table. In this step, we will add sample user data into our DynamoDB table so that we have data we can use later on in this project. DynamoDB is the data storage spot for us. So we're definitely going to need it to have any user data in our web app at all. Okay, so once the table status changes to active, that's when we select the user data table and explore some table items. Exploring table items is just another way for us to create things. So we click on explore table items and we find this panel that tells us we have 0 items because it's a new table, and that's how we can create something new in there too. So let us click on user data let us find the explore table items button. And that's how we can find that we have 0 items so far. So let's create something. I love this part. As we create, we are not going to just fill in some form today. We're actually going to play a little bit with the JSON view. So much fun because under the hood, DynamoDB is storing your data in JSON. So switch to JSON view so you can edit your data in a code format, start to speak the DynamoDB language a little bit more. It's also just a great way to save time. If you have a data with lots of attributes, can you imagine every single attribute, click add new attribute, pick from here, type in the value, add another attribute, type the value, add another attribute, pick the type it in. It can take a lot of time. Imagine if a piece of data has about 30 attributes, then whew, that's a bit much. So let us get used to using the JSON view, which is a more scalable and a more efficient way of expressing data you want to add. And you can actually turn off view DynamoDB JSON. Can you see the difference? As you can see, there's a bit of difference between DynamoDB JSON and just the traditional JSON. DynamoDB JSON also has a little s here. Okay, and that is because DynamoDB JSON needs to store the type of data that you're storing. Is it a string? Is it a number? It's like the different options that you can see in the form view actually. String, number, Boolean, null? What is it? The DynamoDB JSON needs to remember that, and that is the reason why it's slightly different from traditional JSON. But that's okay. We can keep using the traditional JSON, and DynamoDB JSON usually can figure out what the type is based on what you put in. So we're going to say we're going to store some data for a user ID of 1, and then we can say that there's a name for this user, it's test user, and here's their email too. So if you were to sneakily click into DynamoDB JSON, can you see how it intuitively picks up that all of these fields are strings? Great. So when that's done, I think we can take a sneaky screenshot and put that into our documentation. All right, let us add it in. Phew, add it in. And I think there's something I almost missed, so let's talk about it. So the JSON code defines a new item. That item represents a user. It has the user ID, the name, the email. And notice that we just mentioned that the partition key for our database is user ID, but we never really had to specify, oh, we also have a field called name, we also have an attribute called email. We never had to say that. We just straight away added a new data item that just had those attributes. And DynamoDB is not throwing a fuss. It's fine. That's because DynamoDB is schemaless. Schemaless like this. So it means you can add attributes as you need. Every item in your database can have a different set of attributes. So imagine I can just do user ID of 2, address of something, phone number of something, and that's totally okay. The second user doesn't even need to have the same attributes as the first one. It can have completely different ones. So that is what we mean by saying DynamoDB is very flexible. Okay, we've taken a screenshot now, we've added it to our attributes, we've added it to our documentation, and let us answer this question. In our DynamoDB table, in our DynamoDB table, what do we add? We added a piece of data. DynamoDB is schemaless. which means that the data we add can come with new attributes, and every piece of data can have its own set of attributes without affecting other data. Okay, very good. Is there anything else about schemaless? I think that is all we need to say about schemaless. All right, we're all done. A big shout out to the chat as well. I know that there's been a bit of fun activity going on here. I can see Alex is now asking, when we get an idea towards a project, how do we choose the appropriate AWS services? Do we first draw which services to use and how it's going to be executed? Oh, I see. I see. Cool. So when you have a project idea, usually you do draw out the rough architecture of your solution. And sometimes you will need to refer to existing architecture patterns for you to figure out what your pattern is going to be. What I'd recommend checking out, Alex, is to actually check out the AWS Architecture Resource Hub. And that's where you can find existing architecture patterns. For example, 3-tier architecture is a pattern in there. You can also find other existing solutions and how people have built them. And hopefully that gives you a bit of inspiration around how you can build yours. Absolutely, before you actually start building anything, the ideal case is that you just draw out everything first and just have a rough idea of how it's going to connect together before you start to just go into the console. Because the design stage or the architecture stage is where you can actually explore all the other services you could be using, all the other options you could be doing, ways you can connect things, ways you can make sure security is great. Because the moment you start, you might end up getting stuck in a solution that isn't actually the best one. So I hope that helps, Alex. If you have any other questions, add them to the Nextweek community, or you can follow up honestly right here, because it's a really good question. I appreciate it a lot. All right, so we've created, we're gonna select create item, and then we're gonna make sure it was created successfully. So let's make sure that our DynamoDB item is listed in the items return tab. Okay, so that's how we're gonna verify that the item was actually created. So let's go down, select create item, and let's spot it now. Can you see it here? Items returned. I hope you see yours. Cool. So you can see we have user ID, the partition key, it's happy because it has its own value, it's 1. And then we also added some attributes called email, name. Nice work, team. So now this is where Lambda function makes its big entry. So now that our DynamoDB table is set up, the data is there, we now need to add the function that can retrieve the data items, the table items on demand. Heads up to everyone that has done the previous project in the series, you're going to notice that this Lambda function actually looks a little different to the previous one. Okay, so the previous one was set up so that you can use it with an API. This one is going to be set up so you can use it immediately without needing the API in the middle. So we're going to be playing around with this version of the Lambda function, but then when we are tying everything together for the last project of the series, we're going back to that API version, okay, because that's the version we're going to be using for the full 3-tier architecture. For the purpose of this solo project, if you're just wanting to set up that Lambda function, you don't really want to set up API as well, then you can just stick with the code that we give here. All right? Cool. In this step, we will set up a Lambda function because this is how we write the code for retrieving table data items. From DynamoDB. Great stuff, team. Okay, so now that we've created the function, we're going to navigate into the Lambda service in the AWS Management Console. If you're new to Lambda, totally okay. Just know that Lambda is a service that lets you run code in the cloud without you needing to manage the service or the computers yourself. Lambda will just manage all of those servers for you, which is why it's called a serverless service. And the great thing about Lambda is that it only runs code when you need it, so you're not paying for any idle time. It also scales automatically. So if you have just a few requests today, just a few people wanting to search for items, Lambda can serve them. But on days where you have explosive traffic and so many people are trying to search for items, Lambda can also serve all of that big crowd of people too. It can do both. It's really good. And because it only runs code when you need it to, it only charges you when the code is being run, which is a lot more cost efficient compared to having to manage your own servers if you're someone that doesn't need that much compute power. So the AWS Lambda, I would say, is great for solutions where you aren't needing to process a lot. You might notice that as you become more experienced with Lambda, people start complaining that Lambda is actually a very expensive solution. And that's because maybe what they're trying to run is very process intensive. They're trying to run things that require a lot of processing time. And maybe the traffic is so high that is happening so much, which is why you end up racking a big bill. And on that tangent, that's the reason why, like Alex mentioned, it's so important to actually map out, draw out your architecture, draw out what you're building before you start building, because the decision between Lambda and EC2 instances or containers really comes down to how you envision the product to look and how many people are going to use it. All right, so yeah, that's a whole tangent, but I appreciate you listening. So that was about Lambda, and Lambda, just think of it as serverless. You're just running code. Think of Lambda as running code, and think of Lambda as something that reacts to events. So when you trigger it, it's going to run, and once it finishes running, it's just going to go back to sleep. So we're going to be creating a Lambda function, basically a piece of code that we need to run. And we're going to go into Lambda now and let us create a new function. So you can head into the Lambda console, and you can search Lambda here as well. If you don't know how to find it, click on it and then click on create function. Okay, here you are. So what is the function that we're going to create today? I wonder. We'll find out soon. Let's first explain what is AWS Lambda. AWS Lambda is a serverless I would say AWS is a service that lets us run code without having to manage servers. We're using Lambda in this project to create a function, i.e. a piece of code that retrieves data from a DynamoDB table. All good. Thank you, team. Okay, so for this function, we're going to author it from scratch. We're going to give it a nice, cute name, and then we're going to go into the details of function setup after that. Oh yes, we do have a function with the same name, which is the function we created earlier in this marathon. And for anyone who might be watching this afterwards or watching this video solo, because we were doing this project in sequence after two other projects, I do have a saved function in my account. You probably won't have the same issue as me, but if you do, you can simply add a little number to the end of this to make your function name unique again. Okay, add that. You're not going to run into any issues, you'll be okay. And then we can go straight into creating the function. Very nice. Cool. And as a little extra for the pros, if you're wondering what these values are when you set up your function, runtime basically means the language or the environment that we're using to run the code. So you can also have Python, runtime, Ruby, Java. Wow, so many different options. Python is a very popular one. Node.js definitely popular too. And Node.js is basically an environment, or sorry, a runtime for JavaScript. And we have architecture here, which defines the actual physical processor of the server that's going to be running your code. You're not going to care about or manage this processor, but Lambda is going to. So from the start, it just wants to make sure that it's choosing the right processor for your work. Okay, let's just create the function now. And what's next for us? Oh, I just realized I might have skipped this in our setup because we don't need to actually edit this. We just need to look at it and just know what it means. Let's actually look at that together now. Pardon me, everyone. Oh my goodness. But this is what we were looking at together. We don't need to change it again. If you've already clicked on create function like I did, there's no worries. There's nothing you need to delete or change. But have a look at this part of your create function flow. Notice that there is something that says changing the default execution role, and that there is a whole section about an execution role here. What a name! Execution role. Do you have an inkling on what you think this might do or what it might mean? Add it to the chat. What do you think an execution role does? Luckily, it doesn't actually execute people. An execution role is actually just about the permissions for your Lambda function, what your Lambda function can and cannot do. In our case, we're just creating that new role with basic Lambda permissions, which is why we don't need to change anything. It's already the default setting. But an execution role gives Lambda the power to access other services and do things with other services. When you create a new role with just the basic Lambda permissions, that means that your Lambda function will just have the permission to write logs to CloudWatch. When your Lambda function has run successfully, sometimes it'll say, oh, run successfully, here's your output. And those logs, they can be written because it has permissions to write those logs with CloudWatch. Another use case, your Lambda function does not run perfectly. There's been an error. How do you see the error message? Luckily, because Lambda already has those basic permissions to CloudWatch, it can write those error logs so that you can troubleshoot your errors too. Anyway, really glad that execution role already has those permissions for us by default. But let's go back into our function now because we're ready to actually set up its code. Shall we go on to the next step? Cool. Here's where we can write your explanation for your function's execution role too. My Lambda function has an execution role, which is the set of permissions that it has to interact with other AWS services. By default, the role grants basic Lambda permissions, which are the permissions to, do you know what these permissions will grant? These are the permissions to write logs with CloudWatch, e.g. success or e.g. error logs. All right. This is great. Yeah, and once you select it, there's even an option here that says Lambda will create an execution role named this, has a special ID at the end, with permission to upload logs to Amazon CloudWatch. Oh, perfect. Just like what we mentioned. I think what I'm going to mention here is that we're going to come back to your execution role in a second. It's good to recognize that your execution role already has a name that you can come back to later. Okay, we've created the function now. It's out there in the world, but is it actually doing anything? Okay, the answer is no. Okay, right now our function isn't actually doing anything right now because we haven't actually written the code for your function. The function is one thing, the code is another thing. You can create a function, which is basically this presence or the ability for you to have this kind of almost like I almost wanted to say container, but I think that's a confusing way to use the word container. So I want to say that a function is almost like setting up this piece of paper that's blank right now, but once you write it, you have the power to give it the ability to run some code that's going to turn into processing data, uploading photos, some very productive like actions that you can take. Anyway, right now we've just set up a blank piece of paper. So let us actually write the code that's going to go inside that piece of paper by filling out the code source. That's what we'll be doing in this step. In this step, we will add code to our function because that's how we define what the function can do. Great work, team. So in our Lambda code editor, this is where we can just copy the code and put it straight into our code editor here. Don't worry if you're new to code, if you find it a bit intimidating, we'll still go through what it means and explain it too. Hang in there, let's talk about it in a second. It's just that the first thing you need to do is make sure you replace the your region placeholder with your own region. So for us, that's US West 2, because I'm in Oregon. But make sure you actually map up your own region and get its region's code and type that in there. Okay, cool beans. Now, let us head back in here to talk about what this piece of code is doing. Now, the first half of the code uses a special set of tools called the AWS SDK to interact with DynamoDB. That first half of your code, it takes a user input, grabs the corresponding data, like this. It takes the user input, grabs the corresponding data from DynamoDB, and hands it back to the user. Easy as pie. And a big shout out to Abby. Thank you so much for the lovely compliment. I love your profile pic, by the way. Abby says, love your content. Thank you, Abby. And the second half, this one, is all about just giving you messages based on the output. If it was successful, then it means that there was some data that was retrieved. Unsuccessful, it's going to give you an error message, a straight error in the code itself, or sorry, not in the code itself, but more in if you're not even able to get any code because of some errors in the connection to DynamoDB, for example, that's when you'll say unable to retrieve data. But if the code actually works, it's just that the data doesn't exist, then that's a different error message too. Cool. Now, we mentioned AWS SDK earlier. So what is AWS SDK? Let's see if we can use Simplify to talk about it. Oh, perfect. It's just like our definition down here. SDK is a set of tools that really makes it easy for you to interact with your AWS services. You use AWS SDK for your applications. Okay, so you use the management console to log into AWS on your browser. You use the CLI to log into your AWS account over the terminal. Then what is SDK for? You use SDK to log in to AWS and interact with your AWS resources over your application code. So here you can think of AWS SDK as a set of code that makes it easy for you to interact with your services. Not just about getting access, actually, it's not really about getting access. It's more about having ready to go pre-written code that you can use as functions so that interacting with the services themselves is very easy to do. Otherwise, writing all of the code required to interact with the AWS services is actually a bunch of API calls. We've set up an API earlier in the series. You've seen that it requires a bit of steps. Being able to use those APIs and trawl through all of the documentation for those APIs would take a bit of time. So AWS SDK is here to make the use of AWS services in your code a lot easier. And yeah, there's a different SDK for different programming languages. JavaScript is one of them, and that's the SDK we're using in our code. So as you can see, it's import. We're importing DynamoDB from SDK, and that's the reason, and we can even import a specific command from SDK, and that's the reason why we can use DynamoDB related actions in our code too. All right, let's get on with it. Our Lambda function will retrieve data from a DynamoDB database table. The first half of our code is all about the data retrieval and returning it as output. The second half of the code is all about actually sending responses. I would say the first half of the code is all about the retrieval, and then the second half of the code is all about sending responses back, e.g. success messages, item not found messages, straight error messages as well. Great. The code uses AWS SDK, which is, my code uses SDK too. Okay, this is where you can do a little bit of explanation on SDK itself. The code uses AWS SDK, which is a set of tools that makes it easier for developers to use AWS in their application code. Our code uses SDK to get access to DynamoDB actions, i.e. read or retrieve data items. Cool. So we have made sure that we've replaced that your region placeholder in our code. So we're actually ready to deploy it now. So let's click on deploy. All right. And deploy basically saves it and pushes it out into the world. Not exactly pushing it out to the world, actually. It just makes it usable. You can now test it to see different kinds of outputs. Deploying it also means that it's now able to be used. It doesn't necessarily mean it's like open to the entire world, like it's public, it's out there, but depending on the permission settings you've put, you can now start to use it. Cool. So we've deployed it, and while we wait for the deployment to be successful, let's take a screenshot of our function's code. Nice. Awesome. Let us select done now that we've uploaded the code and check, is the deployment a success? I'm face palming because I'm making this mistake the second time in a row today. When you deploy your code, I think it's going to say no changes to deploy because I haven't made any changes now. But you can easily see the deployment success message. There you go, deployment successful. And I'm just going to quickly change that back to the right region for me. There we go. Nice, deployment successful. Happy. With that done, we're actually just down to the last two steps of this project. For our last two steps, we need to first write a Lambda function test, which means our function code is deployed, so it's technically usable. So why don't we test it and see if it does what it's supposed to do? Can it actually retrieve data from our database? Let us see. In this step, we will test our Lambda function by trying to use it to retrieve data from the DynamoDB database. Because the function is now deployed, i.e., it's usable. Okay, so let us head on over to our Lambda function and let us select the test tab at the top. Okay, and your test tab is like a playground for your Lambda function. This is where you send fake events, or fake events is the best way to put it, just to see how your function would react to it. So imagine if a user did request to retrieve some data based on a specific user ID. You can now start to write different tests with different user IDs and see how your function will react. Is it doing its job correctly? So in the event.json panel, we can enter the following piece of JSON to test this event. What happens if someone were to test a retrieval of data using a user ID of 1? They just want to see what is the piece of data that's related to this user ID. Shall we just click on test and see what happens? Succeeded. Woof, that's nice. Oh, and also, the reason why we also wrote the data in JSON, by the way, is because we're asking a Lambda function to search for an item, which means that we need it to be in a format that Lambda can actually understand and work with. So event.json is one, but there are actually a lot of different other templates for different kinds of output or inputs that you want to put for your request. So look at that. All different kinds of inputs, and usually it's all in JSON because that is the format that Lambda is quite familiar with. Anyway, for us, we put this in and it was a success. So good. Let's see, what are the details of the success? Oh, once you uncover your success and you open it up, that there's actually an error inside. Okay, for some reason, the function says that it's a success, but the message in the details panel says something else. Aren't we glad we actually opened the details panel? The reason why it's green and it says that it's a success is because your function successfully ran. There were no issues in getting your function code to run. This would have been an error if there was a key error in the function code itself. Maybe you're referencing certain regions that don't exist. Maybe you're referencing certain functions that don't exist in SDK. So those would be actual errors in the code that would stop your function from running. For us, the function actually ran. The entire function ran good, no errors in the code, but there was an error in what we were trying to do. Can you tell what the error is and why we ran into this error? Give you another second to read this and try to understand why we ran into this error. All right, let's have a look. Ooh, before we talk about that, let us actually answer the question on how we tested the Lambda function itself. I'll quickly put in an answer to this, and you're more than welcome to start writing your own suggestions around why you think we ran into that error. To test whether our Lambda function works, what do? We wrote a function test in the test tab in the Lambda console. The test is written in, do you remember? It was written in JSON. If the test is successful, what will we see? I definitely jumped the gun for us here, but this question is a really great way for us to make a guess on what we'd see if the test actually ran perfectly fine. So if the test is successful, we'd see the correct piece of data in JSON when we query for user ID of 1. But you've got an error. Okay, so if you got this error instead, it means that it means that you maybe didn't get to change your region's code back in your Lambda function. So double check whether your code here actually has the right region. Does it actually say a correct region? Okay, and then back to our own error over here. Back to our own error here. Let's take a screenshot and let's talk about why we ran into the error. Team, let's add that screenshot of our error and talk about why we ran into it in the first place. Even though we have an execution role for the Lambda function, remember what permissions that execution role gives Lambda? It gives it the permission to write logs to CloudWatch, but it doesn't actually give it permissions to DynamoDB, which is the actual service that our Lambda function is trying to use. Look, our function code literally mentions DynamoDB, but the function code doesn't actually have access to it. So the moment you try to retrieve data, it's probably going to block you. Because Lambda can't read any items, it has no choice but to tell us that its access was denied. Like we mentioned before as well, the reason why it was in a green success banner is because the code itself could run. There were no errors with the code, it's just that it's now a permissions error that we've run into. The test displayed a success because the function itself ran with no errors, i.e. no syntax issues, or no syntax or dependencies and issues. But the function's response was actually an error. Because, why was that? Because our Lambda function is trying to retrieve data from DynamoDB, but does not have permissions to DynamoDB. Okay, so the Lambda function is retrieving data from DynamoDB without actually having the right permissions for it. So because of that, its access was denied, and we can't actually successfully run this function yet. Let us run into step 6 of this project, which is all about granting DynamoDB the access to Lambda. So we're now going into DynamoDB's permission settings, or we're going into our Lambda function's permission settings, so that it has access to DynamoDB and has the right to read the data inside those tables. In this step, we're going to grant our Lambda function read access to DynamoDB. Why is that? Because it needs read access in order to retrieve the database tables items. And I think that's it. It just needs access to retrieve the database tables items and finish running successfully. All right, cool beans. So let's go into our Lambda functions configuration tab and see if we can update its permission settings. Remember that execution role that was created for us? This is the shortcut that we can go to actually edit the permissions under that role. What's fun is you can actually go into the existing role that your function has. Just try expand it. Be a little curious. Ask yourself, what policies or what permissions does it currently have? Look at that. The permissions it currently has, creating a log group and also creating a log stream, both of them are relevant to just storing records of things that have happened inside the Lambda console. So really glad that it automatically has those rights when you create basic permissions, but let us add some permissions so that our policy or our Lambda function can actually get access to DynamoDB. So we're going to type in DynamoDB here. We got 4 that we can pick from. Interesting. Okay, so we have 4 different permission policies that grants access to DynamoDB. Which policy do you think you should pick? Would you like to give it a go? How many policies, which of the 4 here do you think is the right one for you? Oh. All right, team, you can make a suggestion here. Maybe the policy that gives full access to DynamoDB. Add whatever suggestion or inkling that you might have about the right permission settings. Great stuff. So to figure out which permission policy you want to apply, usually it's best to just head back to the error message and figure out what are you blocked from doing, what's stopping you right now. So let's go into the Lambda function test again and just read the error message. What is the specific action that is stopped from doing? Get item. Yeah, that's right. I think someone in the chat has it. DevOps methodology. Nice work. Get item is the one action that it's blocked from doing. It's not authorized to perform it. If we were to work backwards from that, we know we're blocked from get item. Naturally, we should pick the policy that gives us access to that action. So does this policy let us get an item from DynamoDB? No, you can't actually find get item here. Just get records. Okay, not really get item. Let's keep going. Is there a get item here? Doesn't seem like it. All right, so these two policies are not the right one for us because they don't have get item in there. Let's keep going. What about read-only access? Can we see get item here? We can. So we can find get item here. That means read-only access is the right permission policy to use to give ourselves before we move on. So before you ask, you might be wondering, what about full access? This last option, we didn't check that. Yeah, that's correct. So full access usually means it gives you complete power. Anything you might want to do in that service in DynamoDB, you can do. The reason why we wouldn't do that is because of the principle of least privilege. So this is a security principle where you don't give resources or people more permissions than it needs. So in this case, our Lambda function only needs to read the data that's inside your DynamoDB table. It doesn't need the power to add data, delete data, update data. It only just needs to read. So that's why read-only access is the perfect permission policy for this use case. Let's add our permissions, and voila, it's here. Very nice. I think we have a few questions we might need to catch up on, so let's do them now. To resolve the access denied error, what do we do? Okay, to resolve the access denied error, we are providing our Lambda function with the permissions to perform get item on a DynamoDB data table. This is because, thank you so much, Eric, in the chat for mentioning, thank you for sharing your time and knowledge. That's so sweet of you, Eric. That's really kind. Thank you so much for the lovely message. All right, this is because, why are we performing get item on a DynamoDB table? This is because this is the action that Lambda is currently blocked from doing. To resolve access denied, actually, we've already mentioned to resolve the access denied error at the start here, so I don't need to repeat myself. So let's just go over the full answer here. To resolve the access denied error, we are providing our Lambda function with the permissions to perform get item on a DynamoDB table. This is because get item is the action that Lambda is currently blocked from doing. It is the cause of our access denied error. So let us click done to submit that, and let us head back to our policy. And yeah, this is a bit of catch up on what we were talking about just now. The bottom two permissions, if I were to why don't I actually remove what we've just created so I can go back to where we were to explain this one thing again. So when we typed in DynamoDB, so these last two functions, that's what this is trying to explain here as well. What do these two permission policies do? Okay, they don't let you even read an item, so what good does it do actually? So these two actually are very helpful for DynamoDB streams. DynamoDB streams you can think of as like an event-based newsfeed of data that's been changed in DynamoDB. Has there been a change in a data? Has there been new data that's been creating? But it's almost like a newsfeed log that's like what's new about your DynamoDB table. So it doesn't really let you get an item because you're not going to read items that have already been sitting there for months or years or days. It's more about you can now see what are the latest updates, what are the newest things that's been happening. This is a great use case for Lambda because imagine if you can use a Lambda function to just get triggered when your DynamoDB table updates. Oh, when a piece of data in my DynamoDB table gets deleted, please alert the team over email, for example. Cool. So let's give this a quick answer. There were 4 DynamoDB permission policies we could choose from, but we didn't pick the other 2. Even though they had Lambda in the name, so isn't that so tempting to pick them? Literally have Lambda in the execution role name. So we didn't pick either of those policies because they relate to DynamoDB streams. i.e. live updates of table items that have changed. Great. So with that done, we have decided on picking on read-only access, and we have mentioned that because of the principle of least privilege, we're not really going to be using the full access permission policy. We don't need it because read-only access gives us everything that we need. So with that done, we can take a screenshot of the DynamoDB permission policies and which one we end up picking. Alright, so let's explain that too. We also didn't pick DynamoDB full access. So let us copy that cheekily and mention that here. We also didn't pick the full access permission policy because it would give our Lambda function the permission to do too many things with the table. The read-only access option was the right choice because it secures our table from unauthorized access through Lambda. Great stuff, team. With that done, I think we can move on to the very last step of this project. All right, so let's click Add Permissions. Let those permissions add. Okay, and when you're ready, let us get into retesting our Lambda function. Let's validate whether our Lambda function works now. Okay, in this step, we will retest our Lambda function to validate whether it can now retrieve data after fixing up those permission policies. Okay, so let's rerun the test. Head back to the Test tab in your Lambda function, and let's select test one more time. Oof, what do you think is going to happen, team? I'm feeling a little nervous now. Okay. Whoa, look at this successful test. You can actually see that in the details panel, instead of an access denied error, you can see that the data is right here. You have the email, the name, and the user ID of a piece of data. And this is exactly the data we inputted earlier in this project. You can even still see it in our items panel here. Perfect. Isn't that so satisfying to finally see the right piece of data come back out? So good. All right. Here are some use cases of what you've built today. Now that you can build like a serverless backend for web apps, and now that you can use Lambda functions to grab data from a DynamoDB table, this is a great use case of serverless backend for web apps. For example, Lambda can help customers find products, get product information. It can help social media apps fetch user profiles, retrieve all the content that's within the profile. You can also use it as a content management system to store news sites or blogs that Lambda can fetch very easily based on the user query. So let us take a screenshot of our successful results and wrap up with the secret mission and some last few questions. So let us give this a go. Congratulations, guys. That was such a successful test. This feels so good to look at. So let's take a screenshot of the successful test. If you can see this, please add a little emoji to the chat so we can celebrate together. What a win! All right. To validate our new permission settings, what do? We retested our Lambda function. The results were a piece of data and its 3 attributes: email, name, user ID, because that is the exact data that we inputted in our database at the start of this project. What a great way to know that it worked. So nice. So what are some ways that you could use what you've learned today? Web apps are a popular use case of using Lambda and DynamoDB. For example, what we could do, we could use Lambda to retrieve product information, user profiles, content, e.g. blogs or news articles, based on user queries or actions in our web app. Nice. Feeling pumped, guys. We just have a secret mission to go, and then that's the third project done too. And this secret mission is a pretty cool one. A lot of people are interested in security, which is why the theme of this secret mission is on security for our Lambda function and the DynamoDB table. Now, DevOps methodology in the chat has also asked previously about security. So I hope this is something that we can all learn a little bit more from too. Your mission, should you choose to accept it, is to actually update your Lambda function's permissions again to even better secure your database. In the secret mission, we're going to be updating your Lambda function's permission policies one more time, and then we're going to try validate that the function could still work even with some stricter permission policies. So you know how we chose read-only access? What if there's a way that we can put on even stricter, tighter access so that our Lambda function truly can't do anything else aside from retrieving data items from DynamoDB? Okay, if this is something that you've been interested in, security, now is your chance to learn how you can secure your database and also secure connection between Lambda and the database. Let us unlock the secret mission. That looks amazing. I can never get sick of that. That looks so good. All right, what are we doing now in this secret mission? In this secret mission, we will tighten security once more by rewriting our Lambda functions permission policies to DynamoDB. This would enhance our database's security. Data security must be so important. Out of all the different things that you could be securing, like network, there's data, there's your application itself. Oh, so much that you could be securing. I was actually going to say data must be one of the most important ones, but the moment I said out loud network security, like that feels very important too. So I can imagine why cybersecurity is just so important across the board. Okay, team. So how are we going to tighten security for our Lambda function even more? Let us go into our Lambda function again. Do you remember how you could edit its permission settings? I hope you remember. We were doing it just 30 minutes ago. You had to click on configuration, and here is where you can select permissions from the side tab, and then select the execution role, which determines all of the permissions that your Lambda function has. We're going to be tightening security today, so we're actually going to make things even harder for our Lambda function. Okay, all right. We're going to tighten security by first removing the policy we just gave it. So let us select it, select remove, and then create an inline policy instead. So this inline policy is going to replace the ready-made managed policy that AWS has given us. So while the managed policy can give us read-only access to the DynamoDB tables, the inline policy gives you even more granular control. So this policy that we added gives you read-only access to all the tables in your account. In our case, Actually, our Lambda function only needs read-only access to the user data table, that specific table. So we can use an inline policy to make things even more granular and to specify that it's only this resource that you can use. So let us mention that for our project extension, we challenged ourselves to replace the permission policy we granted our Lambda function previously. Instead of the AWS managed policy, we'll make sure it can only access user data. This will enhance DynamoDB's security very nice. So let us actually go ahead and delete the managed policy we do not want anymore. We're going to say bye-bye. I'm going to click on a cheeky remove button, remove that away. And then we're going to add our permissions using inline policy this time. So again, we're not attaching policies like you've seen already. There are a set of 4 permission policies we could use. And even the one that we ended up picking, which gave the perfect amount, like the right permission without giving away everything, we still decided, you know what, you're still giving away permissions to too many things. So why don't we just write the permission policy ourselves? So let's create it ourselves. And wow, there are 2 different options for creating policies ourselves. There's the visual way, so you're going to be using drop downs and forms to prepare your policy. And there's also the JSON way. Ooh, so this is the more advanced way, where you're actually just writing the policy code by yourself. Aw, we got Maximus Suarez. Who is this person? First time? Joking. To anyone who hasn't met Maximus yet, he is an absolute legend himself in the team, working on all sorts of content. You would have seen his face in a YouTube short, a TikTok, an Instagram reel before, I'm sure. Otherwise, a LinkedIn post. Thank you, Maximus. All right, so your pick. Do you want to do this in the visual editor or in JSON? The final policy you actually create is going to be the same. It's just that the process looks a little different. So with the visual editor, you're using the more beginner-friendly interface with checkboxes, you have drop-downs, and then JSON is when you're just going straight into writing that policy code. It's a bit more challenging, but it is a more efficient solution if you just know if you're becoming more and more familiar with policy writing. Yeah, thank you so much. Let's get into it. And a shout out to Roger for saying hello from Mexico. Hello, Roger. All right. Why don't we go for the visual editor, the more visual way to do it, and then we'll just sneakily switch over to JSON at the end to just see what that would look like as well. In the visual editor, you can stay on this tab, and then you can select the service. What service are you trying to get access to? DynamoDB. And then what actions are you going to allow it? We know exactly which action it was blocked from before, right? It was get item. So let us put in get item here and select get item. And now this is going to be the only action that Lambda is allowed to do. Not even the other actions that were allowed under the read-only access policy. So it's going to be a lot stricter now. Ooh, and you can even specify which resources this would apply to. Is it all DynamoDB tables? Nah, it's a specific one we're giving access to. So let us select add ARNs to be specific about which DynamoDB table we're trying to apply this to right now. The resource region. Which region was your DynamoDB table created in? For myself, just click into the console, by the way, if you're not sure. But for myself, I know for a fact that it's US West 2. So let us put in US West 2. And what is the name of our table? Do you remember? User data. All right, so you can even copy that over, paste that in, and there you go. That's your resource ARN. Isn't that also a nice little hint on how resource ARNs are created? You just need your region and your table's name, put that together, and you have your ARN. Of course, it has other data that it already has put in for us. We're using an ARN. It's an AWS resource. This is the service category. Here's the region you put in. This is your account ID. This is the type of resource within the service. So within DynamoDB, we're creating a table here. We're not creating an item. And then the table's name is user data. Okay, so let's add this ARN now. And there you go. That's your policy already all created. You have your service figured out. You have the actions it should be allowed. And then you've even mentioned which specific service this applies to. If you switch that to JSON, look at that. You can even see the code version of the exact permission policy we just created. If you were to go for the JSON version of this task, of the secret mission, you can see that we already have that JSON code prepared for you as well that you can use immediately, but you just need to make sure to manually replace the ARN yourself. Okay, so that you're not referencing any random table. You're using the table that belongs to your account and in the region you set it up in. Okay, so let's take a screenshot of our setup page, and that will be our clue for wrapping up this secret mission too. Okay, so we're almost done this one, and we'll just upload that into our project as well. To create the permission policy, what did we use? We used the visual editor because this was a more user-friendly and guided option for creating our custom policy. Did we already write about the policy previously? I don't think we did. Oh, we did. This involved checkboxes and drop-downs that we picked, and the policy was written in the background. Okay, all done. Okay, so we're going to just finish up creating that policy now. So we're going to click next here, and we'll enter in our policy's name over here, which is user data read access, and then create that policy. So once that policy is created, it was created within our Lambda execution roles page, which means that it automatically is applied to our Lambda execution role. Great, that's good news, because it means we don't need to do anything more to add. We can go straight into testing the Lambda function's permission straight away. Oh, Rohan messages, it's pretty late here in our Eastern time zone. Thank you for all your efforts. I will follow along on the video in the morning. Thank you, Rohan. It's been lovely to have your presence here. And seriously, hearing you share your answers, mention a few comments throughout this live has honestly made it such a great experience for ourselves too. So thank you, Rohan, and we'll catch you in the next live too. Hope you have a good evening. Alright everyone, so we're almost done as well with our secret mission. So let's go back to our Lambda function and let's test it again. So we're going to go into test, And let's click test one more time. What do we think? All right, it still succeeded. So that means that even with the limited permissions that it has, our Lambda function could still grab the data from our DynamoDB table. Okay, so that is a huge win because we could perfectly narrow down our permission policies to exactly what our Lambda function needs. We tested that it still works. So that is very much the principle of least privilege at work here. Woo! Well done to you. So let us just enter this and we're almost done with our project. When updating a Lambda function's permission policies, you could risk losing access to resources, actions it needs to work. We validated that our Lambda function still works by retesting it after updating its permission policies. And yes, still worked. Perfect, all done. Okay, so next is to clean up all of your resources like your Lambda function and your DynamoDB table, and all of the instructions for those are over here as well. When you're done with deleting those resources, just make sure that when you're in this page actually for deleting your DynamoDB table, that you keep this one checked but this one unchecked. So confusing, but this is the system or setup you need to make sure you don't get charged. Just a quick heads up. Okay, and what were the services we used for this project? Services we used in this project were Amazon DynamoDB and AWS Lambda. Key concepts we learned include Lambda functions and what did you learn from this one today? Lambda functions, adding table items, that was something we did, testing Lambda functions, how to select the right permission policy, and then even writing custom inline policies as well. That was amazing. Okay, this project took us approximately, around 1 hour and 15 minutes, including demo time. The most challenging part was probably writing the inline policy. It was something that's very new to us. But it was most rewarding to see the right data pop up when we ran a successful function test. So we did this project today to learn about the data tier, of a 3-tier architecture. This project definitely met our goals as we learned how to connect it to AWS Lambda, which is the logic tier, as well. So good to start having integrations between tiers. Alright, and that's a wrap. So you've also built a Lambda function that retrieves data from a database, no servers required because Lambda is a serverless solution. You've learned how to set up a DynamoDB database, create and configure an AWS Lambda function. You even wrote code to interact with DynamoDB using the AWS SDK that was in your function code. Next, we tested the Lambda function. We even tightened some security settings so that we are following the principle of least privilege. That was an awesome finished to like the data tier as well of our 3-tier architecture. And you can click mission accomplished right here. Oof. Okay, again, we're seeing that one of our answers weren't submitted. So let's try that again. Okay, so let's try that one more time. Poof, off we go. Can we do it now? Yay, it worked. Okay, we're pro. We finished this project. That was awesome. And let us download our documentation and wrap up for this project too. Alrighty, so we know that this is already 12 hours up as well for the project marathon, which is insane. That was 12 hours of AWS projects. I can't believe it. That was an amazing feat. Oh my goodness, look at the amount of live time that happened today. I think this is about 2 months worth of live time.
Yeah.
In one single day.
Pretty mega.
Pretty mega.
Pretty mega.
Yeah. Look at this amazing documentation we also just set up and we can put into our portfolio. So make sure you download your documentation at the end. And once it's downloaded, add that to your portfolio over here. Okay, very cool. Nice work. So we're just gonna upload our project, and that is all 3 tiers for the 3-tier architecture complete, which is very satisfying. Now I'm just gonna pause for a second to give you time to ask any questions you might have across those 3 projects, because I know that was quite an intensive feat. We did the logic tier, the presentation tier, the data tier all in one go. So here's a quick little 30-second break for you to just ask any questions, and then we can do Q&A on them too. All right, so we have one quick question from DevOps Methodology. How do you handle caching and invalidation in CloudFront? I love this question so much because caching and invalidation are 2 really great features of CloudFront. So when you set up your CloudFront distribution, you can actually alter its cache behavior and also some of the features of its caching. So how often should it cache? How should it route to the origin if there's no copy of the resource in the edge location? So you can definitely set all of those up. And invalidation is so fun. So invalidation in CloudFront is all about whether you can just almost reset the memory of all of the edge locations that have a cached copy of your website content. So say you make an update to your website and you want to force everyone to load the latest version of your website so that no one is seeing an older version because maybe there was a big error there, maybe there was something that wasn't supposed to be there. You just want to see that change rolled out everywhere quickly. That's when you would use invalidation in CloudFront to force all of the edge locations to refresh their memory, and the next time someone tries to see your website, they're going to see the most recent version instead. Invalidation is honestly very straightforward and easy to do DevOps methodology. All you have to do is click on the invalidation tab when you're inside CloudFront. Okay, quick 30-second demo. When you're inside CloudFront and you have your distribution open, all you have to do is click on the invalidation tab here, and then just create an invalidation. Type in the specific file path or which file you want to invalidate, so which file you want to force reset. You can go star to say all files in my bucket I want to do a hard refresh, or you can do just the index.html, for example. Create invalidation, and it's going to roll out that change across all of the edge locations that have this file stored. So the moment it says complete here, you're all done. The file has been refreshed in all of the edge locations. No cache copies of the old version. Yeah, I hope that was a good brief recap for your question, DevOps methodology. And it is amazing, again, to know that our 12 hours is up. Congratulations, everyone, and wishing you all a very happy holiday and Christmas season. I hope you have a lovely few weeks. If you are taking some time off, I hope you have a lovely break. If you are staying on, continuing to work, continuing to learn over this break, power to you, sending you some extra positive energy for that too. Now, because the 12 hours are up, it means the final part of our 3-tier architecture series, we will be running that as a usual live session on the first week that we're back, and that's going to be the week of 6th of Jan. The live itself, it will probably be around the 10th of Jan. That's when we'll be going through every single piece of this 3-tier architecture series in the final wrap-up project. I'm so excited to be doing that with you, and we will see you then. Amber, would you like to wave bye as well as we wrap up? Bye!
See you later. Bye-bye.
Thank you so much for all the good vibes over the last 12 hours.
Oh yeah.
Yeah. Oh. And we'll see you in the new year.
See you in 2025.
Thank you, everyone. Bye.
Bye.